Yes, dear student, here I am with new topic meter bridge. Meter bridge. Meter bridge is form of V-stone bridge. Actually, a meter bridge is again a V-stone bridge. Here a wire AC of 100 centimeter length and of manganese alloy is taken thin wire and uniform portion area. These are thick with copper strips. Thick means their resistance is going to be zero. These are thick copper strips and having gaps. Actually, this whole point is A. This point A is here. And this point is C. C point. This is C point here. And this is D. Between A and D, there is resistance R of known value. So there is a device called resistance box. There is resistance box from which we can take value of 1 ohm, 2 ohm, 0.1 ohm, 0.5 ohm resistance can be taken from resistance box. This R4 RB means resistance box. As is a known resistance. Across point A and C, we connect a cell and key K1. The galvanometer is connected at point B and other end of galvanometer connected jockey. So all points have come A, B, C, D. Now, I will tell you all things later, but explain you this is one experiment in the lab to find resistance of S by meter bridge. It is called meter bridge because YAC is of 1 meter length. Meter. This point B and D form a bridge here, between which we connect galvanometer and a jockey. These connecting wires are of copper, thick wires of copper. When they are kept in lab or anywhere, copper taking moisture from air and oxygen, in presence of moisture, copper reacts with oxygen to form copper oxide, which is bad conductor. So when you connect this wire here, clean the ends neatly with the help of sandpaper and then connect. Every point, this is very important here. In lab, I have noticed students or even teachers are unable to find S because they don't take this precaution. The end point of connecting wires should be clean. Actually, this is very sensitive device. A slight variation in value, any value of R may change the position of null point, balance point. These are taken thick strips so that the resistance is supposed to be zero. Now when we keep code K1 come throw in R A B C D, we take some resistance from here R and then S is there, we place jockey. So to check the circuit correctness, first we place jockey at point A. Deflection and galvanometer come one side. The galvanometer scale होता है 0, 10, 20, 30, 10, 20, 30. So deflection will come one side, and if we place jockey at C, near C, deflection come other side. So circuit is correct. Otherwise, somewhere it is open. Now when you have got checked, So then put the jockey at wire AC at different place and find no difference in kilometer. That point should be here B and it should be closed at the midpoint. Why it should be at the midpoint? I told you in the last video the sensitivity of meter bridge. Sensitivity of meter bridge, Wolfram bridge. It shows maximum sensitivity when the all four resistances of bridge are of equal values. इक्वल वैल्यू होगी तो सेंसिटिविटी हाई होगी, नहीं तो लो हो जाएगी. लो सेंसिटिव मीन्स एरर will occur there. So we should try there in lab while doing this experiment that R should not take in large because the wire here S is of manganese again. It may have hardly resistance of 1 ohm or less than 1 ohm. Sometimes it may be 1.5 but not more than that. And take sufficient length of wire, manganese wire AC. In the lab, take sufficient length of wire S. Nearly 50 centimeter लेंगे तो then it will come out nearly 1 ohm. So here resistance should not be taking 10 ohm or 15 ohm. Only 1 ohm, 0.2 ohm, 0.5 ohm, 1.5 ohm like that. Then only you can get null point near the midpoint because if P upon Q is equal to R upon S, you will get null point. And for high sensitivity, we keep the value of PQRS. This is P resistance, this is Q. Resistance of length AB is P and the resistance length BC is equal to Q. So how to do? I am repeating again. We close key K1, take some resistance from here and then put the jockey at wire AC and note the null point distance of null point from here on meter scale. Suppose this length is L, then this will be 100 minus L. Now what will be P? As you know that R equal to rho L upon A. R equal to rho L upon P equal to rho into L upon A. Rho is the resistivity of wire of manganese. Why manganese wire is taken here? This is a very good question here. I told you manganese has low value of temperature coefficient resistance. And its resistance does not change with the increase of temperature considerably. And we can assume constant of wire AC. Resistance of wire AC may be taken constant for the entire time of doing experiment. So, and Q will be again rho into 100 minus L upon A. So P upon Q equal to L upon 100 minus L. In balance condition, P upon Q equal to R upon S. But in balance condition, P upon Q equal to R upon S. And therefore we get here R upon S is equal to L upon 100 minus L. We know R from this box, we know L from here, we can find out S will be 100 minus L upon L into R. So by knowing the value of null point from point A and by knowing the value of R, we can find out S. We can verify here the series parallel from equivalent of series parallel also. Now, if we know the length of this wire and cross section of this wire, we can find out resistivity also using this formula. R equal to rho L upon A. The length ना बनेगा एरिया कैसे by measuring diameter by screw gauge you can find out area cross section. So this was about potentiometer bridge. Now there are very good questions on meter bridge and on conditional balance bridge. To find the equivalent resistance, etc. So please do this experiment sincerely in your lab and try to understand from practical book and theory book also. Now I will try some question based on this. Okay, I'll take in next video.